Severe organ failure is a major problem in the United States. Thousands of people require organs to help save their lives, but one of the biggest issues we face is there isn't enough. So what's a big solution to that? And that's 3D organ printing. Every year, thousands of patients wait for organ transplants, but the number available is scarce. Many patients die before ever reaching the top of the list. And even when an organ becomes available, rejection is a major risk because the immune system recognizes it as foreign. So the challenge is double. We don't have enough organs, and the ones we do have aren't perfectly compatible with every patient. So how does it work? Bioprinting uses specialized printers that layer living cells called bioink to build tissues and eventually full organs. These bioinks are often created using the patient's own stem cells, which means the printed organ is personalized and far less likely to be rejected. There are three main areas where the doctors can collect stem cells for the bioink. This is known as adipose tissue, otherwise known as fatty tissue, bone marrow, and peripheral blood, or blood collected from the bloodstream. Now let's look at some major steps. First, doctors collect medical images of the organ through a CT scan or MRI, creating a general blueprint for the project. Next, cells from the patient, often stem cells, that can be transformed into the types of cells needed for the organ, then multiplied and differentiated into specific tissue types. After using a bioprinter, the cells are deposited layer by layer along with the supportive biomaterial scaffold that shapes the organ. Finally, the printed structure is placed in a bioreactor, which provides nutrients and stimulation so the tissue can mature, develop blood vessel networks, and start functioning. Although 3D organ printing is a major solution to the issue of healthcare access, it's also important to note that there are still some challenges with the solution, especially with complex organs such as the heart, lungs, and liver, especially with the major problem of vascularization, which is maintaining and creating new blood vessels within the organ. Researchers are also working on strengthening tissue durability, improving maturation speed before cell death, and navigating the ethical steps needed before reaching hospitals. Although that may seem a little complicated at first, it's actually easy to break down. So listen, let's just break down vascularization quickly and why it's so important. Vascularization is not only blood vessels, but it helps carry nutrients such as glucose and amino acids, as well as vital oxygen to different organs in the body. However, since we are printing these organs and it is not connected to the body yet, it doesn't have as much access to these nutrients which allow it to grow and develop. And this is where our issue starts, especially when we want to strengthen the tissue. So why does this technology matter? First off, it could dramatically reduce organ shortages by allowing us to print organs on demand. Second, it can reduce immunorejection because the organ is derived from the patient's own cells. This solution allows us to understand human physiology better overall, which allows us to lead to more breakthroughs and help us understand how life-saving treatments don't have to be defined by matching availability or luck.